Now, what about those special systems that we saw earlier? The ones where the two lines were parallel, or the ones where they were actually the same line? What happens with those when we're using the substitution method? Let's say we set out to solve the system y equals negative 1/2 x plus 4 and x plus 2y equals 1. This is well set up for substitution. We'll substitute y from this equation into this equation, and we'll get x plus 2 times this thing that's equal to y equals 1. All right, let's distribute. X plus 2 times negative 1/2 will be negative x plus 8 equals 1. Look what happens when we combine like terms. We have x plus negative x. That's 0. We're just left with 8 equals 1. What? Is that true? No, this is false. 8 doesn't equal 1. No matter what x is, no matter what y is. We've just discovered that at any point that makes this system true, 8 and 1 have to be equal. But that can't happen. Right, so this is one number equals a different number. That tells us that there is no solution. There is no value of x or y that can make 8 equal 1. Therefore, there is no solution to this system. What kind of system is this? This system is inconsistent. What if we set out to solve this system? Again, well set up for substitution. We have x alone in this equation, and we can substitute x into this equation. We'll have 3 times this thing that's equal to x plus 5y equals 9. All right, we'll distribute. 3 times negative 5/3 y will be negative 5y. 3 times 3 will be 9, plus 5y equals 9. Now again, when we combine the like terms, the y's are eliminated, right? And we're just left with 9 equals 9. Now is that true? Well, yeah, sure, that's true. Right? And that's true no matter what x and y are, right? That tells us that putting these two together somehow doesn't give us any new information at all. We'll get a number equals itself after we substitute if we have infinitely many solutions. That is, what do we call a system like that? If the system is consistent dependent. So when we had the consistent independent systems, the ones with just one solution, we eventually found a value of the variable this way. If we get a number equals a different number, there's no solution. If we get a number equals the same number, there are infinitely many solutions.